Once again, a very good morning and a warm welcome to all of you for the course called Engineering Statistics and Linear Algebra. So I hope you know the credits for the subject. I hope you know the credits for the subject is 03. 3 credits are allocated for the engineering statistics and linear algebra. So in today's class, I will glance a complete overview of the subject and will discuss all 5 models in brief. Means I will introduce all the 5 models. Later, I will tell you the basics of a set theory and the probability. So these two concepts are essential. These two concepts, that is, what do you mean by set theory and what do you mean by a probability. These two are essential for this subject. I can call them as a prerequisites for this subject. For that reason, after the discussion of the overview of the subject, we will discuss set theory and the probability. Right? So can you quickly tell? All right. So what are the objectives of the course? I will discuss them first. It is so important. So why this subject is to be studied? That's the first discussion here. We should study this subject because first objective, understand and analyze the single and multiple random variables and their extension to the random process. So the first objective of this course is you will be knowing what you mean by a single random variable, multiple random variable, then what you mean by a random process. Second objective, compute the quantitative parameters for the functions of single and multiple random variables. In the first objective, definitions and concepts of them are studied. After studying the concepts, we will apply for the quantitative study. Okay, so by taking a few examples, a concept of a single, multiple and random process will be studied, right? Then it's what. So the first objective, first we will study the concept called a single random variable. In second module we will discuss about a multiple random variable. In third module we will discuss about a random process, right? So while discussing, we will take a few examples. Then the same concepts are studied with respect to the electronics and communication engineering related issues. So the first and second objectives are related to the engineering statistics, and the third objective is related to the linear algebra. So this subject is completely divided into two topics here. The first topic is statistics and the second one is a linear algebra. Module number 1, 2, 3 are related to the statistics, and fourth and fifth module are related to the linear algebra. Keep that point in your mind. Then the third and fourth objectives are related to the linear algebra, a familiarization with the concept of a vector space, what you mean by orthogonality, then the compute the quantitative parameters for the matrices and linear transformation. So in the fourth module, we will study a complete information regarding a vector space and orthogonality, and in a fifth module, we will see concepts of matrix and linear transformation. All right, these are the objectives of the course, engineering statistics and linear algebra. Fine. So I will glance what you mean by module 1, then what we will cover in it. First we will say what you mean by a single random variable, definition of it, what you mean by a CDF, cumulative distribution function, then what do you mean by a continuous random variable and a discrete random variables. PDF, a PMS, PMF, what is that? A probability, a mass function, probability density function and its properties. So after the completion of this, we will go for expectations, then characteristics functions, functions of a single random variables, Then the important concept that is called as a conditioned random variables. Then all these things are studied with respect to the following applications, that is uniform probability, exponential, Laplace, Gaussian, binomial, and Poisson distributions. So all these concepts are discussed with respect to these special distributions. Inform, what do you mean by inform distribution? Probability, exponential probability distribution, Laplace, Gaussian, binomial, and Poisson distribution. All these things are discussed, and the same discussion will be applied for all these concepts. That's what the first model. In the first model, it is completely says it completely gives the information regarding a single random variable. Right? Then we'll go ahead. Model number 2. It is what a multiple random variables. Multiple means it should be more than two or more than two. Here we do consider only a multiple random variable. In the sense here only two random variables are considered. Multiple means two or more than two, but in this case we will consider only two random variables, right? So CDF and PDFs are discussed in the module number 1. They are related to a single random variables. The same definitions, then same concepts, let it be applied to the two random variables or a multiple random variables. Two expectations are discussed in the module number 1. It is for a single random variable, and the same discussion, but it is applied to the two random variables. Then we will study what you mean by correlation, orthogonality, and independence. Transformation, how to transfer one variable into the another variable and vice versa. Then Gaussian random variables. Then how to add two independent random variables. Then sum of IID random variables. Then here we will see one for theorem that is called as a central limit theorem. Then a conditioned joint probabilities. In the model 1 also we have studied a conditioned single random variable. Here also we will see the conditioned joint probabilities. Then application exercises to these three things, right? So in first module we discussed application exercises to the different probability distributions. Here the multiple random variables, they are applied with respect to the following exercises. So you do not worry. So we will discuss in detail about all these things. The overview of the engineering statistics and linear algebras, a course overview. All right. So module 3 means a random process. So module 1 is a single random variable. Module 2 is a multiple random variable. So module 1 and module 2 concepts are one and the same, but in module 1 it is applicable for the only single random variable. In module number 2 it is applicable for the two random variables. That's the only difference. Concepts are same. Only the extra things are added to the module number 1. That's called as a module number 2 here. After the discussion of the module number 2, we'll go ahead a random process. So PDF, independence, expectations will be studied. Stationarity, correlation functions like ACF, CCF, addition and multiplications will be studied. What do you mean by ergodic random process? So specifically we will see what the meaning of ergodic random process. Then what do you mean by a power spectral densities? Most probably you might have heard already in this is not yet studied the subject. So you will come to know what you mean by power spectral densities. So there are different power spectral densities are how they are completely related to the random process. That will be studied here. Then linear systems, its mean, cross correlation, auto correlations of the inputs and outputs will be studied. Then exercises with respect to a noise. So in module 1, 2, 3, all the theory concepts are related to the all theory concepts are studied and they are correlated to the communication related issues, right? So here the issue is considered as a noise. Then how this random process is applicable in the communication channel, that will be discussed in the random process. All right. So have got the idea of statistics, engineering statistics. See the first statistics, engineering statistics. In engineering statistics, what we will be studying? Okay. In linear algebra, it starts in the fourth module. So fourth module covers two important topics. What are vector spaces and orthogonality? Two important concepts are covered in the module number 4, and these two concepts are related to linear algebra. In vector space, we will study what you mean by vector space and null subspaces. Okay. Next is what you mean by rank of a matrix and what you mean by a row reduced form, that is also called as a echelon form. That will be discussed. Then how to say that the given vectors are independent in nature. Then how do you say that, how to reduce the given matrix into a row reduced form or echelon form. After the reduction, then how do you say that how many vectors are independent. Then what you mean by a basis and dimensions. Dimensions of the 4 subspaces. What do you mean by a vector space? What do you mean by a subspace? That will be discussed. They are actually the important concepts. Then what you mean by a rank nullity theorem, that will be proved and applied to the so many problems. Then linear, that will information that will be studied. So all these concepts are covered in a vector space. Then in orthogonality, we will study how to say that the given two vectors are orthogonal in nature. Then how to say that the subspaces are orthogonal in nature. Then projections and least squares. Once the vectors are the orthogonal in nature, then that they can be projected. So that concept will be studied. Then orthogonal basis and one procedure is there. Then a Gram-Smith orthogonalization procedure, that is helpful for the projection procedure. So that's about introduction to the linear algebra. That's about the introduction to the linear algebra. It completely covers the concepts called vector space and the orthogonality, right? Then the last module, that's the 5th module. It covers determinants and eigenvalues and eigenvectors. I hope you already knowing it, you already aware of these two concepts, but that's two very basic concepts. What you have learned and you are already knowing, I feel it's totally a basics level. But in engineering level, these two concepts are totally different and they are at its high peak, right? So in determinants, we will study the properties of the determinants, permutations and the cofactors. Then in eigenvalues and eigenvectors, we will be studying a review of the eigenvalues. Then what you mean by a diagonalization of the matrices. Then special matrices like a positive, definite, symmetric, then their properties. All those things will be studied. Then singular value decomposition, that's the last concept of the 5th module. Hope you have understood what we will be covering in the linear algebra. All right. So the complete subject is divided into 2 parts: engineering statistics and linear algebra. First 3 module covers linear algebra, sorry, engineering statistics, and the remaining two modules will cover the linear algebra. So first module is related to a single random variable. Second module is related to multiple random variable. Third module is related to a random process. In fourth module and fifth module, we will discuss about the linear algebra. In fourth module, we will see what you mean by vector space and the orthogonality. And in fifth module, we will see the meaning of determinants and the eigenvalues and the eigenvectors. Right? So while starting each and every module, again we will discuss the importance of studying the model in detail. Later we will see the in-depth concepts. Right? So next thing is, after the completion of this course, then you will be able to, means they are called as course outcomes here. After the at the end of the linear algebra course, you will be able to identify and associate a random variable and random process in the communication events. It is the first ability you will be having after the completion of this course. You will be able to identify the associate random variables in the random process in communication events. That will be the first ability. And you will be able to analyze and model the random events in a typical communication events to extract quantitative or statistical parameters. This is the second ability you will be having. The third one, you will be able to analyze and model the typical signal sets in terms of basic functions, a set of amplitude, phase, and the frequency. You will be able to demonstrate by way of simulation or emulation the case of analysis employing the basic functions, statistical representation, and eigenvalues. I'm not sure about you will be able to simulate or emulate the things, but you will be knowing the theory part. If time permits, the things will be simulated using the Python codes, and I try to give the proper visualization. If not, I'm damn sure you will be having a proper theoretical knowledge, right? Then these are the textbook you should refer. Richard Williams. So it covers first three modules, means engineering statistics. Then Gilbert Strang. It covers the remaining two modules, fourth and fifth module. All right, not an issue. So I will give the soft copy of this, and this book is available in our library, so you can issue and you keep it with you people. And I will provide notes, not an issue here. No need to refer these two books. If you want more knowledge, then I suggest you to refer these books, but I will provide proper notes along with the video links. Not all right. Okay, so this is what the overview of the subject. Next, I would like to introduce a set theory. Actually, it is not in the syllabus, but it is essential. So quickly we will see what you mean by set theory. I hope you already studied it, right? Just I will cover set theory and probability in 5 to 10 minutes. Already you are knowing, just I am refreshing all these concepts because these are essential in module number 1. For that reason, I am refreshing this. What is set theory? So set theory, what is first set? What is set? Set is a structure representing an unordered collections. It may be group or plurality. Zero, in that group there may be a zero or more distinct objects. We will see. A set theory deals with the operations between the relations among the statement about the sets. Set theory, you can say we have seen a set. A set is a collections of the unordered objects. Right? What is set theory? Set theory deals with the operations of the sets, relations among the sets, statement about the set. Set theory deals with the relations, operations, and statements of the set. It's what set theory. Then how to denote the sets? The sets are denoted using any capital letters. It may be S, T, U, anything, but capital letters are used to represent the set. Then we can denote a set S in writing by listing all of its element in curly braces. So S equals to open curly bracket, these are the objects, close the curly brackets. It is a set of three objects denoted by A, B and C. Right? This is what one set. It should be named with the help of a capital letter. Alright. Here a set can also be said with the help of the statements. What is that statement? For any proposition or any inverse of a discourse. Here X is a object and it belongs to P of X such that X is an integer where X value should be greater than 0 and less than 5. Alright, I repeat here. It is what? One set. Here objects are not given, instead statements are given. That statements gives an object. What is this here? X. For this X, condition is written here. What is that condition? X is an integer where X should be greater than 0 and it should be less than 5. That means 1, 2, 3, 4 are the objects will be available in this set X. Right? So directly we can write the objects, or else those objects can be written in terms of the statements. See here, no matter what objects A, B, C are denoted, so they are distinct. They are one and the same here. So here the same set is used, but A, B repeated, but this has at most 3 elements, but same elements are repeated here. See here, if you want to say that two sets are declared to be equal if and only if they contain exactly the same elements. We have said capital V, capital S, capital T, all these notations can be used to represent the set. If you want to say two sets are equal only if they should have exactly the same elements. Alright, so consider this set here, set 1, 2, 3, 4. It can be here the objects are given directly. The same set can also be written as X. X is an integer where X is greater than 0 or X is less than 5. Does this statement give the same answer? Yes, obviously it gives the same answer. What is that? X is an object, its value is an integer, condition is X is greater than 0 and X is less than 5. It is nothing but these 1, 2, 3, 4. It is nothing but 1, 2, 3, 4. Meaning this set and this set, they are one and the same because they do have the same objects. Alright, let us consider the one more set here. What is that set? X is a positive integer whose square is greater than 0 and less than 25. Then obviously we will get 1, 2, 3, 4. Square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16. So elements are in this set whose squares are greater than 0 and less than 25. It is nothing but again 1, 2, 3, 4. Here three sets are said and they are equal because objects of all these sets are one and the same and they are identical. If that is the case, means we can say that they are identical assets. Infinite set. See here the natural number. Example for infinite set. Let us consider a natural number, integers. It may be having n number of elements. So that's called as a infinite set here. Examples for infinite set, natural number and integer and real numbers, right? So null vector means null set. Null set means empty set where no objects are available. So it is denoted with the empty curly braces. So you know it is a union operation, A intersection of the A union B, means as a result of this it will be having elements of A as well as elements of B. You can take an example here, A B C union 2 3. So as a result we will be having A B C 2 3. So 2 3 5 3 5 7. As a result we will be having 2 3 5 7. Here 3 and 5 are repeated. Here 3 and 5 are repeated. As a result they are written only once. So this is what diagram 2 3 5 7. All right. So I would like to say the already you know it, just I am refreshing all these concepts. So interest ABC, as a result of this we will get a null vector, a null set. As a result of this we will get a null set because no common objects in the two sets. Here as a result we will get only 4. See here 3 2 4 6 3 4 5. In these two sets only 4 is common. That's why that's the result here. So what do you mean by a disjointness? Two sets joint, a disjoint if their intersection should be a null vector, a null set. If you want to say that the given two sets are a disjoint sets, the condition is intersection of those two should be a null set. If that is the case, means we can say that those two sets are a null sets. And example for this, one set is a even set, a even numbers, another set is a odd numbers. Always they are disjoint because even set and odd set, they don't have any common factors, right? So I will give some identities here, set identities. A union null vector gives A only, A intersection with universal set gives the A only. Just we take a screenshot of it. Already all these things will be knowing by you people. So associative property, a commutative property, a double complement of a given set gives the same set, original set. So A union A gives the A only. All these things will be if you want you can take a screenshot of it. Okay, this is what I wanted to say, and in 2 minutes I will say the what you mean by probability. What is probability? Probability means a possibility. It's a branch of mathematics that deals with the occurrence of random events. Always probability lies between 0 to 1. It cannot be a negative number and it cannot be a more than 1. Always its value lies in between 0 to 1. A meaning of probability is basically the extent to which something is like to happen. means we are predicting whether it is possible or not possible, whether whether it happens or not happens. Just it is a prediction. That's called as a probability here. So the definition for the probability: a sum of observations divided by a possibility. Sum of observations divided by a possibility. So just to take an example here, when a coin is tossed, what is the probability? Either it may be head or a tail. I repeat, when one coin is tossed, the result is either head or the tail. This is called as a probability here, right? So how to calculate it? A sum of observations divided by possibility. Possibility means how many possibilities are here? There are two possibilities. There are only two possibilities. Either it is head or a tail. There are two possibilities. So one coin, it is called as a sample space. All possible outcomes are called as a sample space. When a single coin is tossed, what are the possibilities? Head or a tail. So number 2. Then what is the probability of getting head when a coin is tossed? How many times head will occur here? Only one. So 1 divided by 2, it is 50%. We can predict a 50% of the possibility of getting head when a coin is tossed, or else we can expect a 50% of getting tail when coin is tossed, right? So it is called, what is the sample space here? A sample space is total outcomes or outcomes of the event. That is called as a sample space here. Okay, when two coins are tossed, then possible outcomes are 4. When two coins are tossed, these are the possible outcomes. It is called as a sample space. It may be head tail, tail head, or tail tail. All right. When three coins are tossed, what is the possibility? It may be head. So sample space of when 3 coins are tossed is 8, right? So you just keep these points in your mind. Okay, in next class and onwards we'll start a single random variable.